Good morning. Welcome to today's lesson. Last time we discussed on the question that I handled in paper 1 of chemistry, and we found that there are papers that just talk about short or brief answers. Now today we are going to look at sections of paper 2 which deal with long question answers. And we are going to focus mostly on the periodic table questions, which gives us a lot of maths. Now we can have a sample of the periodic table whereby uh, we use letters to represent the first 20 elements of the periodic table and ask ourselves some simple questions on the periodic table. Now there are 20 elements of the periodic table starting from hydrogen all the way to calcium. And the elements of the periodic table have different atomic numbers, and the different atomic numbers contributes to the atomic numbers. The atomic numbers contributes to its position, to the position in the periodic table. In the periodic table. Now, starting with the first element of the periodic table, which is hydrogen. You can have the periodic table. This one is hydrogen, which is denoted by H, then helium. Then from there we get the first 20 elements. We arrange them in terms of the outermost electrons, from hydrogen to helium, which is number 2. Then the atomic arrangement of helium, or the atomic configuration of helium is 2. Then from there you go to helium, which is 2, 1, because it's atomic number 3. Now, the outermost electrons are the ones that determine the position of an element in the periodic table. Now, the position of hydrogen, since it has only one outermost electron in the periodic table, in the outermost electron, we are going to place it on the first one. This one is referred to as a period. The vertical one is the one that we call it a group, and these ones are the ones that we call as a period. So across the period, we have the elements. We have an increase in the number of outermost electrons, or the number of energy levels increasing across the period. Therefore, from hydrogen to helium, then we get to lithium, which is 2, 1. Then the lithium boron. Then from there we get sodium, magnesium, aluminium, and so on and so forth. Therefore, a question may come and ask, for example, here we have a question that is telling us that the paper consists of 3 elements. The elements have been represented in terms of letters instead of the real elements. Now, suppose here we have given letters like A, B, C, suppose this one is C and D, E and F. Then here we have the transition metal elements. Then from there, you have G, H, I, J, K, L, F, and so on and so forth. Then a question may ask to explain, or just to see the electronic configuration of element G. How do you see the electronic configuration of element G? You just count from the top left until you get the position of G, where we say this is 1, 2, and 3. That means element G is atomic number 3. Having an atomic number 3 implies that the electronic configuration is 2, 1. Therefore, for us to get the electronic configuration of G, we just get as 2, 1, since the atomic number is 3. Another question we come and ask, sometimes we are provided with the real atomic numbers. Like for example, we have element A and B, where A has an electron configuration of, instead of being given the electron configuration, we are given the atomic number like 20 and B has 12. Then we are being asked to compare the melting point of the two. Compare the melting point of A and B. Now the melting point of A and B can be compared after stating the electronic configuration of the two elements. Now the electronic configuration of the two elements, the first one will be 2, 8, 8, 1, since the first energy level occupies a minimum of 2 electrons. The first energy level occupies a minimum of 2 electrons, and the second one occupies a minimum of 8 electrons. And the last one, the second last occupies a minimum of 8, whereas the last occupies a minimum of 2. That one is element A. For element B, the distribution of electrons along the nucleus of the atom, this one is the nucleus, the distribution of electrons along the nucleus of the atom, then will be 2. B, remember it has an electron configuration of atomic number of 12, and the configuration will be 2, 8, and 2. Therefore, the distribution of electrons around the nucleus will be, remember this is the nucleus, so the first one will be 2, followed by another 8, and the last one will be 2. Now, for us to compare the melting point of the two elements, we have first to consider the nuclear charge. The nuclear charge. Or you either compare the nuclear charge or the bond energy. So between the two elements, which one has the highest bond energy? And how do we determine the bond energy? The bond energy is determined by the force of attraction between the nucleus and the outermost electrons. Now, since the nucleus for the first element, which is A, the nucleus is so much far away from the outermost electrons, we expect the force of attraction for the nuclear charge to be very low. Therefore, the bond energy for the first one will be very low due to weak force of attraction between the nucleus and the outermost electrons. Now, for the other one, since the nucleus is close to, the distance between the nucleus and the outermost electron is very short, we expect it to have a high bond energy. High bond energy, and therefore, since the bond energy is high, then we require a lot of temperatures to break the bond, so that a reaction can occur. Therefore, since B has a high bond energy, it has a high melting point. A high melting point compared to A. Now, there's another question that can also be asked. Explain the melting, which element will react. In terms of reactivity, remember we have just talked about the melting point. Now, another question we ask to explain the reactivity of the two elements. How reactive are the two elements? Or how does the reactivity of the two elements compare? Now, the first thing that influences the reactivity of elements is what we have just seen, which is the bond energy, or the force of attraction between the nucleus and the outermost electron. The force of attraction between the nucleus and the outermost electron. Remember, these are the outermost electrons, and the distance between the outermost electrons and the nucleus is very long. Since there is a long distance, then it shows that the force of attraction between the nucleus and the outermost electron will be very weak. Now, since it is very weak, then the outermost electron can be easily lost to other atoms. And the loss to other atoms is what is referred to as the reactivity. Now this one is for air. For air, we have a long distance of attraction between the nucleus and the outermost electrons, leading to the low reactivity. While for B, the force of attraction between the nucleus and the outermost electron, as we have seen, the distance is very short, and that means that the outermost electrons are strongly attracted to the nucleus and very difficult to be lost to other atoms. To be lost to other atoms. Now, the difficulty of being lost to other atoms is what causes the high or the low reactivity. The low reactivity because it requires a lot of energy to remove the outermost electrons so that they can react with the other elements. Now, another question we asked to write the reaction between. Now the two of them are metals. You can be given another element like element Q, which has an electron configuration of 17 or atomic number 17, and another element P, which has an electron atomic number of 16. Then we are being told to write a reaction, an equation for the reaction between elements A and P. Now most students confuse this kind of a question. Instead of writing the real or the letters given, they just assume that 16 is oxygen, which is also correct, but according to the question, then one is supposed to be writing or to be explaining, to write an equation which shows the elements being given. And the elements being given are only two. They are only two, that we have A and B. And for A, element number A is 20, and the 20 means that it is 2, 8, 8, 2, and element B is, element P, which is reacting with A, is atomic number 16, which has an electron configuration of 286. Now, the second most important thing is to know the valences. The valences of the two elements. The valence of the first one is 2, because earlier on we said that the valence of an element is determined by the number of outermost electrons. The number of outermost electrons for the first case is only 2. Since it is only 2, then it means that the valence is 2. The valence is 2 because it loses 2 electrons for it to form an ion, and therefore this gives us the valence for element A. For element B, the outermost electron is 6. So we can see the valence is 6 because it forms ions by gaining. So since it gains 2 electrons to form P ion, it gains 2 electrons to form P ions. Therefore, the valence is 2. The valence for P is 2. Now, a reaction between A and P can result into a given compound, and that's what we are being asked to do. The first element is A, which is valence 2, reacting with element P, which is valence 2 also, even though we do not indicate the valences, so that we can get element AP. Element AP, in which the valences are 2 and 2. Now, for us to know the exact elements, we don't indicate the valences. We just exchange the valences so that we can have 2 here and 2 here. Then dividing by the smallest number possible, and this one will give us 2 and 2 will cancel so that we can remain with 1, which is simply, and if an element is 1, like AP, of course we know here it's 1 and 1, we don't indicate 1, we just put A, showing that it is already 1. It's already 1. Any number without a power usually means that the number is into power 1. Therefore, since we know that A has 2 electrons at almost energy level, and A is a metal. Therefore, A is a solid. For P, P is a gas at room temperature, and the AP is a compound formed when A and P react. A reaction of A and P forms a compound. How do you know the form or the state of that compound? Now, you just try to think on, if A is a metal, then it means that A is calcium. At the back of my mind, we know that A was calcium and B was oxygen. So after reacting calcium and oxygen, you get calcium oxide. Now calcium oxide is a solid at room temperature. Therefore, you expect your compound to have a solid state. I think I'm well understood. Now for the second one, you can have a reaction between B and Q. Between B and Q here. Now, as we have done for the first part, you have to list the atomic numbers of the two of them, and then state again the atomic number of B is 12. That means the electronic configuration will be 2H2. For Q, the atomic number is 17, which shows that the electron configuration is 2H7. Now, the second thing to do is to know the valencies of the two elements. We have said that this one forms ions by gaining the last two atoms electrons, and therefore the valency becomes 2. For Q, it is very easier to gain one electron than to lose the outermost 7 of them. Therefore, we expected to lose only one, or to gain one electron to form Q, Q negative. That means the resultant electron or the resultant ion will be Q negative. For B, it will be B2 positive because it gains 2 electrons. We say that elements form ions by gaining electrons to form positively charged ions, which are simply known as cations, and therefore B forms ions by losing 2 atoms electron to form B, which has a positive charged cation, or which has a positive charged ion, which is known as a cation. Now for Q gains only 1 electron to form Q negative, and this negative shows that it has gained 1 electron to form an ion. Now a reaction between B, which is a metal, and the Q, which is an nonmetal, forms a compound, and you want to know the formula of that compound. How do you reach the formula of the compound? Remember, we have said that B is in valence 1, Q was in valence 1, and B was in valence 2. From 2, we said that we extend the radicals. After the exchange of the radicals, we find that Q takes the position, or Q takes the valency of 2. That means if you have B, which is valency 2, and Q, which is valency 1, then Q takes the valency of B, and B takes the valency of Q. So in short, we exchange the radicals, we exchange valencies. After exchange of the valencies, we find that Q takes position 1 and B takes position 2. Then after the exchange of valencies, we end up getting the real compound, the real name of the compound, which becomes B1 and Q2. Then we have said that if you have B, or if you have 1 here, we don't indicate the 1. We just ignore the 1 and write the one which has a bigger number than 1. Therefore, the compound formed between, for a reaction between B and Q, will be B1, B, which is simply 1, and Q2. Now the other step is to know the physical states. The physical states of the elements present, and the physical states of the elements present. Remember, we have said that B is a metal because it forms iron by losing atoms electron. Any element forming iron by gaining or by losing electrons forms a positively charged ion, and the ion is simply known as a cation. Therefore, as we have seen, B forms ions by giving two outermost electrons, and then after giving the two outermost electron, it forms a positively charged cation. Therefore, we know that P1 is a metal, and metal is in a solid state. For Q, Q is a compound that forms ion by losing. I mean by gaining the outermost electron for it to become stable. Since we have said that it is very possible, since it has 287, it is very possible to gain one outermost electrons than to lose the 7 of them. Therefore, upon gaining one electron, it becomes stable. And we all know that negative charged elements result from a reaction whereby they gain electrons. And negative charged electrons form elements by gaining electrons. By gaining of electrons. Now we have seen that elements that form ion by gaining electrons are all nonmetals. Therefore, and most of the nonmetals are gaseous at room temperature, including our Q. And therefore, that's why we have seen that Q is a gas. Now, what about the physical state of the element or the compound which is being formed after the reaction of B and Q? What is the physical state of the element? Or of the compound, or the product formed between B and Q? Now, we have said that from the back of your mind, you know that B is position 2, and that means that this one is magnesium, even though you should not write it here, and Q is chlorine, which is position number 17. This one is chlorine. So upon a reaction between magnesium and chlorine, you expect to have magnesium chloride, of which we know this one is a solid at room temperature. So a reaction of metal and a metal in most times forms a solid compound. Therefore, this one is a solid. Now, the last step is to know to balance the two equations to make sure that there is a balance of the elements in the product side and the reactant side. Now, on the reactant side, we have only one P, which is equivalent to one P on the other side. But we have only one element in Q, and the other one we don't have. We only have one here, on the other side we have two. So for us to balance the two of them, we have to insert a given number so that we can make sure the two of them are balanced. An equation is said to be balanced if the number of elements on the reactant side equals to the number of elements on the product side, then the reaction is said to be balanced. Therefore, for us to balance our equation here, we only insert a 2 and then try to check again whether it has been balanced. So, from the product side, you only have one element of B, which is equivalent to one element of B on the product side. You have two elements of Q and two elements of Q on the reactant side, and therefore our equation is said to be balanced. And that's what is being expected of our student. Now, the last part of the question, if not the least, can tell us to explain the ionic radius and atomic radius of the two elements. The ionic and atomic radius of the two elements. Remember, we have elements A and B was 12, and A was 20, and B was 12. Then someone is telling us to explain the ionic and atomic radius, or to compare the atomic and ionic radius of the two elements. Now, we can start with the atomic radius of the two elements. Atomic radius of the two elements, where we have said that the first one is A and B, then A was 2H2 and B was 2H2. Then how do we compare the atomic radius of the two elements? What about the size? The size of an element is determined by the force of attraction between the nucleus and the outermost electrons. Secondly, we can talk of this one is the force of attraction. Force of attraction between the nucleus and outermost electrons. There is another factor which should be considered, and this one is known as the repulsive forces. The repulsive forces between the incoming electrons and the already outgoing ones, so that you can know the ionic and the atomic ready. So the atomic ready for air is being the atomic ready for air compared to is ionic. Remember, the ionic ready will be one energy level less because it has lost one outermost electrons. Look at this diagram. This one is air, 2H2. This is the first electron, the first shell or the first energy level after the nucleus, then followed by the second one, which is H. This is the distribution of electrons along the nucleus. Then the other one will be H. Then the last one will be 2. Remember, when it forms ions by loss of 2 electrons, so when it forms ion by losing 2 electrons, then it forms an ion which is 1 energy level less. An ion which is being formed here is being 1 energy level less because it has formed ion by losing the outermost electrons. So when you compare the number of energy level for the second diagram, which is this one is A and this one is A2 negative. So when you compare the number of energy levels for the first case compared to the second one, you'll find that this one is 1 energy level less. Therefore, the atomic radius of A is greater than its corresponding ionic ready, simply because it has formed ion by using 1 outermost electrons for it to form an ion. Now for the second case, which is the last one, we have said we compare the atomic and ionic ready. We have compared that the first one for A. For B, we shall have the same explanation. But since they are the same, we can look at that one for Q, which is a different one. And this one is an albedo. For Q, remember, it is position number 17, and the configuration is 287. Now, this one is the atomic ready. We want to know the ionic ready and compare the two of them. So this one forms ion by gaining. Remember, all the metals form ions by gaining the outermost electrons for it to become stable. Remember, the outermost electrons are only 7 of them. So when it undergoes formation of ion, it gains 1 electron. It gains 1 electron for it to form a compound which looks like this. Not a compound in this case, but an ion which has this representation. Remember, since it has gained only 1 electron, the overall charge will be a negative. This one will be negative. Now, comparing the first diagram with the second, you find that even though there has not been a number of change, the number of energy levels have not changed. They have remained constant. Therefore, we can see there will be an increase in the number of outermost electrons. Now, the argument here will be the only incoming electrons are being repelled by the already existing ones. And now this kind of a repulsion is what causes the outermost electrons to bunch outside, and therefore the ionic radius is greater. The ionic radius is greater than atomic radius. Now there are so many questions that someone may encounter when you talk about the periodic table. There are so many of them. We shall keep on looking at them with time. So due to the matter of time, we can stop at this point. and then continue from there next time. Have a nice day.